Assalamualaikum and hello to our lecturer, Dr. Jack Ferbian Rusdi, and to our peer assessors. Welcome to our video demonstration for the BITS1213 Operating Systems project. We are Loke and Keys, and today we will be presenting our setup for the Phantom Leak protocol Secure Quarantine Zone implementation. Our group consists of 4 members. My name is Farisah and I am responsible for configuring the database server. My teammates, Loke and Loong, will be demonstrating the DHCP server, Izzati for the web server, and Alya Maisarah for the SFTP server. In this video, we will be walking you through the step-by-step configuration and testing to prove our internal client has no internet access and can only securely reach our server at 192.168.1.254. Let's begin with the network setup.
Hi, I'm Loke, and I'll be showing how to set up the server and client devices for our Phantom Leak protocol. Firstly, we'll have to configure the network for our server. To configure this, we'll have to open the network settings for our server virtual machine. For this server, we'll be using 2 network adapters. This one will be attached to NAT, which stands for Network Address Translation, that will enable our server to have access to the internet. Next, for our second adapter, we'll be using this for our internal network, which will be used to connect to our client devices. Then, we'll give a special name to our internal network to be used to connect. In this case, we'll be using Loke and Keys. Now, to configure our client virtual machine, for this, we'll only be using one network adapter which will be attached to our internal network only, so that this client remains isolated at all times and only connected to our server. Then, we'll set the name for this internal network the same as our server, which is Loke and Keys. Now, to check if our server has internet access, we ping it to 8.8.8.8, which is Google's public DNS server. Since all 3 packets is received and none is lost, this shows that our server is connected to the internet. To set up the DHCP service for our server, firstly, we would have to update the software list for our server. And then we can proceed to installing the DHCP server software package so we can set up the DHCP and configure it. Since our server has 2 different networks, there will also be 2 different interfaces. We will have to determine which interface is for our internal network. We can do this by comparing the MAC address for the adapter of the internal network with the interfaces. From here, we can see that ENP0S8 matches the MAC address of the internal network, making ENP0S8 the internal network interface. We then need to configure a static IP address for ENP0S8 so it can be used as a default gateway later on. Using the interface file, we add 192.168.254 to ENP0S8, which will be used later. Then we restart the network and we can see that ENP0S8 will always be 192.168.1.254 every time the server starts. Now to configure the DHCP, we would have to open the DHCP file and add ENP0S8 into the interface so that the DHCP knows which interface to use. And we add it in v4 because our addresses are IPv4. Next, we open the DHCP configuration file. And we delete all its content and we add the configuration that we need. So for our configuration, we will be setting the subnet to 192.168.1.0 with a subnet mask of /24, and the IP range would be from .5 to .10, and the default gateway being 192.168.1.254, the same as ENP0S8. Then we restart the DHCP so the updates can be done. And here we can see that the DHCP is up and running. To test if the DHCP works in our server, we now use our client virtual machine and check its IP address. Here, we can see that the IP address assigned is 192.168.1.5, which is within the range of our DHCP configuration, which shows that the DHCP service works in our server. And this ping shows that the client is isolated and not connected to the internet.
My name is Alya Maisarah, and I am going to present SFTP, Secure File Transfer Protocol. First things first, I will be updating our server package list and install the OpenSSH server by typing sudo apt and sudo apt install OpenSSH server y. Next, I need to configure SSH to listen only on the internal network interface. I have to open the configuration file by running sudo nano etc ssh sshd_config. I have to scroll down and type listen address 192.168.1.254, and right below already appears subsystem SFTP. The next step is to create user account in SFTP. I have to run sudo user add and researcher to create account along with the password sudo passwd researcher. We have to apply the configuration by restarting the background by using sudo systemctl restart ssh, and then we have to verify the listening IP address by using command sudo sstrnp grep22. Now on the client side, we have to secure connection by typing SFTP researcher at 192.168.1.254. From the screen, it seems that the key is not known by any other names, so we have to continue by typing just exactly like the instruction given, so that it can permanently edit the IP address. After connecting to 192.168.1.254, we have to type down pwd ls put test.txt, get test.txt, and exit. But it seems that test.txt file does not exist, so I exit and put the file by typing touch test.txt, and then I enter back by typing SFTP researcher at 192.168.1.254 and typing pwd ls and put test.txt where the file appear, and when typing get test.txt, it is available for download, and then I exit.
Hi, my name Izzati Binti Roszaili, B0325107033. Today I will present the web server configuration section of this project. The first step was installing Aperture 2 on the server virtual machine. I used the package manager to install Aperture 2. After the installation was complete, Aperture 2 became available as the web server software that will host our website. The
The second step was configuring the port binding. I edit the aperture configuration file and change the default listening configuration. Instead of listening on all available network interface, aperture was configured to listen only on IP address 192.168.1.254 and port 18. This ensured that only device connected to the internal network can access the web server. The third step was configuring the virtual host setting. I edit the default virtual host configuration file and modified the virtual host directory to use the internal network IP address. This configuration ensured that the website is served only through the internal network interface and cannot be accessed through other network address. The fourth step was creating the web page. I replaced the default aperture web page with a simple HTML page. This page acts as the company portal and allows us to verify the web server is functioning correctly. After completing all configuration, aperture needed to be restarted so that the change could take effect. I restart the aperture service and then check its status to ensure that it was running successfully without any error. The sixth step was verifying the listening address. I used a network command to check which IP address and port aperture was listening on. The output showed that aperture was listening only on IP address 192.196.1.254 and port 18, which confirmed that the security requirement had been successfully implemented. Finally, I performed testing from the client virtual machine using a web browser. I accessed the server by entering the address 192.168.1.254. The company webpage was displayed successfully. This confirms that the web server is accessible from the client machine and is functioning correctly within the internet network.
Once again, my name is Farisah and I will be presenting the implementation and testing of our database server using MariaDB. For the Phantom Leak protocol, this database acts as our secure repository for sensitive operational data because our primary goal is maintaining a strict quarantine zone. This server is entirely isolated from the external internet and is configured to bind exclusively to our internal gateway 192.168.1.254. To set up this secure environment, we first installed MariaDB and secured it using the MySQL secure installation script to remove anonymous access and restrict remote root logins. Next, as you can see on my screen, in the 50server.cnf configuration file, we explicitly changed the default bind address to 192.168.1.254. This ensures the database only listens to requests within our isolated virtual network. Inside the database, we created a dedicated database named Phantom Leak with a sensitive data table. For access control, we created a specific user named internal user. Crucially, we restricted this user's host access using the wildcard 192.168.1%. Meaning connections are strictly rejected unless they originate from inside our designated network subnet. Now, let's verify the setup from our client VM. To prove the isolation works, we connected to the database server from this client machine using the command mysql-h 192.168.1.254-u internal user-p. After entering our secure password, we successfully authenticate and gain access to the MariaDB monitor. When I execute select from sensitive data, you can see that the client can safely retrieve our protected records, such as a sample blueprint file. This confirms our internal routing and privileges are perfectly functioning. During this implementation, we assumed a standard Debian-based architecture for the client VM to ensure the MariaDB client package could be installed seamlessly via the apt package manager. Finally, in compliance with the course policy, Google Gemini was utilized during this project as a learning aid to troubleshoot syntax and structure our report documentation, with all outputs manually validated and tested in our virtual environment. And that concludes the database server segment. Thank you.
In conclusion, our group has successfully implemented the Phantom Leak protocol to establish a secure, fully isolated quarantine zone. Throughout this project, we demonstrated how critical infrastructure services can be hardened against unauthorized access and public exposure. By restricting our DHCP, SFTP, Apache web server and database server to listen strictly on the internal IP address, we ensure total network binding and complete containment within our private subnet. From automatic IP allocation and secure file transfer with the researcher account to hosting our internal company portal and managing protected records, every module was verified to work seamlessly from the client side. This comprehensive deployment proves that proper access control, privilege management, and rigid network isolation are fundamental to securing sensitive corporate environments. That concludes our complete presentation for this subject. Thank you.